Hi, students, and welcome to today's lesson. I'm Mrs. Davis. Today, we will explore the question, how do we describe the view of the sun, the moon, and stars in Earth's sky? Are you ready? Grab your pencil and your science journal, and let's get started. Imagine that you're sailing across the Pacific Ocean with legendary Polynesian navigator Tupaia. You're traveling from one small island to another small island that is 300 miles away. How can you get there? The sun sets and you look up at the night sky. You see a moon and many stars. Tupaia turns your boat slightly to the right. How does he know which way to go? Then you notice that Tupaia is also looking up at the sky. The stars and moon help him know where to steer. In our last lesson, we read about navigators such as Tupaia who use celestial objects to navigate on the open ocean. We realized that humans can use celestial objects as landmarks to help them get from one place to another. But we're still not sure exactly how the navigation works, are we? We think that if celestial objects such as the sun, moon, and stars move, then they must move in patterns. If we can figure out what those patterns are, we can predict where objects will appear in the sky. To help us identify patterns, we observed the sky just like Tupaia did. We looked at photographs of the sky taken at the same place at the same time for 3 days in a row. What patterns did you notice about objects in the sky? Maybe you noticed that the sun appeared to be in the same position in the sky at the same time each day. This is a great observation. But what about the other objects in the sky? Did the clouds appear in the same position in the sky at the same time each day? No, the clouds are different in each photograph, right? I noticed that on April 27th, the sky had almost no clouds, but on April 28th, the sky was almost covered in clouds. And on the 29th, the sky has just a few wispy clouds here and there. So, the amounts and positions of the clouds in the sky are different each day. How interesting. What else do you notice? What stayed the same? Based on our observations, can we predict what we will see in the sky on the next day at the same time? Did you predict that on the next day at the same time, the sun will appear in the same position as it did on the 3 previous days? If so, great job. What other landmarks or objects did you include in your prediction? Maybe you included the fence and trees since those objects remained in the same position each day. Nice work. You may have included clouds in your drawing, but we can't predict where the clouds will be, right? The location of the clouds does not seem to follow a pattern. So, the sun was in the same place in the sky at the same time each day that we observed it. Its location was predictable. But how can people use the sun or other celestial objects to navigate? Well, imagine you're sailing on the ocean. You know that the sun is in the same place every evening. So, you can use this knowledge to figure out where you are and to keep the boat moving in the right direction. What additional information would you need to use observations of the sky for navigation? Were you thinking we would need to know if the sun or other celestial objects move across the sky? I was thinking that too. We would have to navigate differently if celestial objects move across the sky than we would if they stayed in the same place. And if they do move, we would need to know which direction they move in. We would have to navigate differently if celestial objects moved across the sky. We would also want to collect data on the position of the sun or other celestial objects for more than 3 days to see if the pattern changes. In fact, humans have been observing the sky for thousands of years. Throughout history, many cultures have learned a lot from observing the sky. Ancient people from Polynesia shared their knowledge of celestial objects by talking to each other. However, many other civilizations created visual ways to show the patterns they observed in the sky. We can use our observations and predictions of the location of the sun to draw a model of how ancient Polynesians could have used celestial objects for navigation during the daytime and nighttime. In this navigation model, we will want to include any patterns we observed while looking at the sky. Where should we start? Let's split our model in half and make one side daytime and the other side nighttime. Make sure you include these labels in your model. We are navigating in the ocean, so we can include ocean water. And since ancient Polynesian navigators were sailing from island to island, let's include an island in our model as a landmark. Then, we will be able to see where the celestial objects are in relation to the island. We will also need to include celestial objects. Which celestial object should go on the daytime side and which celestial object should go on the nighttime side? To answer this, pretend you're a navigator looking up at the sky. What would you see in the sky during the day? What would you see in the sky at night? What else should we include? One of your tasks at the end of this lesson will be to draw your own navigation model. What objects and patterns will you include in your model? Wow, we learned so much about celestial navigation and early Polynesian navigation. The ancient Polynesians noticed a lot of patterns about the position of celestial objects in the sky, and we observed some patterns together too. What patterns do you notice in the appearance of the sun, the moon, and the stars in the sky? One of your tasks at the end of this lesson will be to answer this question. Imagine once more that you're on a raft at night in the middle of the Pacific Ocean. You look up and you see a clear sky with thousands of stars. You wonder, would the stars look the same if you were sailing in the Atlantic or on the other side of the world? And what if you were looking at the stars from somewhere altogether different? What would you see if you were floating high above the earth in the sky itself? In our next lesson, we'll learn about some people who got to see a very different view of the stars as we continue to explore the question, how do we describe our view of the sun, the moon, and stars in Earth's sky? Let's review your tasks for today. First, draw the navigation model. Second, answer the question about patterns in the appearance of celestial objects.